All right, hello. We're back here for day 2. I tried to do this morning at 8 o'clock, and unfortunately I screwed up YouTube's, the key that I use on YouTube. I accidentally reset it, so even though I was streaming, it wasn't actually making it out to YouTube. And as a double idiocy, I didn't bother to record it at the same time, so I'm going to have to do it again. Let me go ahead and move over to my screen here. So you can see here the day 2 I already did it. At least I already submitted my answers, but that doesn't prevent me from showing you how to do it again. So we can get past this cruft here, at least the story. So to make sure that you didn't mess, we're given a bunch of IDs that are just a bunch of strings with letters. And to make sure that you didn't miss any, you scan the likely candidate boxes again, counting the number that have an ID containing exactly 2 of any character, and then separately counting those that have exactly 3 of any letter. Then you can multiply these 2 numbers together to get what's called a checksum, and compare it to what the device predicts. So here's some examples, good examples here. A, B, C, D, E, F has no repeated letters, so that's not it. B, A, B, A, B, C, that has 2 A's and 3 B's, so it counts for both. So that would be 1 and 1, so we would multiply those together. A, B, B, C, D contains 2 B, we wouldn't multiply them together yet. We have to go through the entire list. A, B, B, C, D, E contains 2 B's but no letters that appear exactly 3 times, so that contributes 1 to that first counter. We're keeping track of 2 counters. The number of times that we see a string that contains 2 repeated letters, and then the number of times that it contains 3 repeated letters. Another example, A, B, C, D, D contains 2 A's and 2 D's, but it only counts once. A, B, C, D, E, E contains 2 E's, so again that counts once towards that first counter. A, B, A, B, A, B contains 3 A's and 3 B's, but again it only counts once. So pretty good, looks like I'm getting cut off. No, this is right. Pretty good explanation there on the problem. Let me check one thing here. Okay, I can't change it while I'm doing this, so I'll go ahead and move this up a little bit. There we go, so that we can all see it. Of these box IDs, 4 of them contain a letter which appears exactly twice, and then 3 of them contain a letter which appears exactly 3 times. So in the end, our checksum here is 4 times 3. So what's the checksum of our input? I already got our input here. Again, I've already solved the problem. Sorry, I didn't end up streaming on the first time I did this. But here's what it looks like. It's just a bunch of strings, and we have to go through and count up the number that have a letter that appears twice, and then count up the number that have a letter that appears 3 times. So I've already cut and pasted this. Here's my input over here. Sorry, that's from day 1. Here's my input. Okay, and there are 250 examples of these. So I'm going to start. This is the code from yesterday. I just cut and pasted it so that I could have some starter code. Let's go ahead and change this. The file is going to be 2.input is what I ended up naming it. Right. And at least it'll give us a starting point for bringing these things in. Now again, I already did this, so I've already looked ahead, and I know that in the second one I'm going to have to keep track of all of these strings. So instead of doing it on the fly, I'm actually going to store them. So let's go ahead and create an array. I think that they represent IDs. We'll call malloc size of char star, and we're going to want 250 of them, 250 strings. And then for each one of those strings, in fact, I'm going to go ahead and put that into a variable and reuse it. For each one of those strings, I'm going to initialize it. Now, I could come over here and get an exact number. That's going to be column 26. So I would need 27 for the null terminating character. So let's go ahead and do that. We'll initialize the ith one. And again, we need a 27 of those. Okay. 27 because each one is of length 26 characters, but then of course we'll need the null terminating character. Okay. We'll open the file using fopen. I've got a temporary buffer here of size 100. I don't want to have to worry about the size there. I don't need a frequency, but I do need a counter, an index value, starting at 0. And I'll get the next line, but before I do that, I will copy over the buffer that gets read in from the file into the ith string. So strcpy into id sub I line, or sorry, buffer, or buff in this case. Now you do have to be careful here because remember that forgets it retains that end line character at the end of the line, that /n character, and we don't want that in there. If we could put that in there, but it's probably going to screw up some of our logic, so I'm just going to go ahead and take it out. So chomp the end line character. So to do that, before we copy it, all I need to do is set the last character to the null terminating character. So if it was 5, like A, B, C, D, and then the end line character is going to be at 0, 1, 2, 3, 4. In other words, the size 5 minus 1. Right? So buff of strlen of buff minus 1 is going to be set to that end line character. Okay. At this point, I've read in all of the strings. I've got 250 strings to work with now here. So I want to go through and count up the number that have 2 characters, and then count up the number that have 3 characters. Now that seems like a repeated task. So what I'm going to do is I'm going to define a function to do it. We're going to go ahead and create a double counter, let's say. Here's our first iteration. Double char count, right? And we're given a const char star, a string, and it's going to go ahead and return it's going to return the number of, or sorry, it'll return true or false. It returns true if s has, say, 2 repeated characters, false otherwise. Okay. So I'm just going to do this as a first exercise, and then we'll take care of the triple character counter as a sequel to this. So I'm going to go ahead. Now, the trick here is that you need to look at the input. You can see that each one of these only contains lowercase letters. At most, there are 26 of them. So what I'm going to do is I'm going to create an array of size 26 that holds a count of each character. So int count 26. Now the idea here is that count of 0 will hold a count of instances of A. And naturally count of 1 will hold a count of instances of B, lowercase b, etc., etc. Now you do have to be careful, even though this is small, it's static. It's a static declaration. It'll be fine for this one. It gets thrown away and popped off the call stack when we're done. There's no guarantee on what's in there right now. There's no guarantee that that's filled with zeros. So I'm going to have to do that manually. I'm simply going to go through, and for each one, I'm going to initialize it to 0. Right? Then I'm going to go through each character in the string, and if it's an A, I want to increment that counter for counts of 0. If it's a B, I want to increment that counter for counts of 1, etc. All the way to Z, I would be incrementing a counter for counts of 25. Now, it might seem at first that that's going to be difficult, but remember, the ASCII text table, a character is a number. You can treat it as a number. So what I can do here is I can say count of something plus plus. What is that something? Well, what if it's an A, right? I want that to map to 0. Now, I don't know off the top of my head what the ASCII text value for lowercase a it's something like 80s or 90s or something like that. But I want to subtract that off, right? Subtract off a, that gives me 0. And that'll map to the first one. But of course, it's not always going to be a, it's going to be s of I. Now, if it's a, then subtracting off the character a gets me back to 0. If it's b, then subtracting off character a gets me back to 1, ... If it's z, subtracting off a gets me to 25, right? All right, good. Now all I need to do, here, I'll put a note here, count up the number of instances of a through z. Right? And then now all I need to do is go through that again and see if there are any instances where the count is equal to 2. Right? So let me go ahead and reuse this code here. And if count of I is equal to 2, then I'll go ahead and return true. Otherwise, if I get through that entire listing A through Z and none of them add up to 2, then I will return false. I did not find a letter A through Z that was repeated twice. Okay. Now, hopefully you see that to do the second part where you need to counter for instances of 3, it's all the same thing except for this right here. This would change to 3. So if I've got a lot of repeated code like that, I'm not going to call this double count, but I'll call it, I don't know, num count or something. I can't think of a better name at this point. So, and I'll pass that in as a parameter, int count. I've already using that, so int x, right? And if it's equal to x, then we'll go ahead and return true. Now I can pass in 2 to this function and get the solution for double counting. I can pass in 3 and get a solution for triple counting, right? Let's go ahead and go back down here. And I'll need to keep track of a total counter, int count 2s, right? And int count 3s. Right? And then for each string, so for int I equals 0, I is less than n, I plus plus. So for each string, see if it has repeated double characters. And to do that, I just need to call my function. Forgot what I called it now, num count. Again, that's the importance of naming things so that you can remember what they're called. Num count on the strings were called IDs, so I and 2. So we'll increment our count 2s. Now this is not a mutually exclusive condition. Remember, we even saw in the problem explanation that some of them can count towards both counters independently, one or not the other, or both or neither. Right? So we'll go ahead and reuse our function here, passing in 3. Okay. Good code reuse here. I didn't have to write 2 functions. I think that was the solution I did this morning, and I didn't like it. So upon reflection on the second try here of streaming, I'm going to improve the design. So I'm just going to go ahead and print all of these out. Count 2s, %d in the line, count 2s, right? And then count 3s, print that out, and then the checksum. The actual solution that we're looking for is count 2s times count 3s. Okay? Let's go ahead and try to compile this. See if I made any syntax or errors or mistakes. Oops. Let's see. I misspelled ins somewhere. Okay. IDs. There we go. There. That was the only issue. Let's run this again. Looks like I've got a bug here, definitely. Count 2s, added. ID sub I. Let's see. Oh, you know what? I never got incremented. There we go. We were always rewriting and rewriting that first string. And so in the very last one, we wrote that last string and then all the rest of them were uninitialized strings, so it was probably just garbage. Or we got lucky and we didn't have a seg fault and it was all just null bytes or something like that. Or it had null terminators in it. Let's try that again. And that's the answer I actually got this morning, 7350. Let's go back over here to Advent of Code and verify that that was the answer. Yep, 7350 was the answer that I got this morning. So this solution is much better than what I did before this morning. There I had two functions. Here I only have one. There are definitely some improvements that can go on here, some error checking that I'm not worrying about right now. I'm just doing this as a quick review. But otherwise, that's part one. Let me go ahead and duplicate this. Part two is a little bit more interesting. Let's go ahead and read that. All right. So, confident that your list of box IDs is complete, you're ready to find boxes full of prototype fabric. The boxes will have IDs which differ by exactly one character at the same position in both strings. For example, given the following, the IDs A, B, C, D, E, that's the first one, and AX, the second to last one here, are close, but they differ by two characters, the second and the fourth, the X, the G up here, and then the Y and the D up here, right? However, the IDs F, G, H, I, J, and this one right here, they differ by only one character, the third character, the H up here, right there, and the U down here. So that is our correct box. What letters are common between the two correct box IDs? So in the example above, we would take this first one and the second one, and then we would delete the character that is different, right? Producing FG, IJ. And so here is my solution from this morning. Let's see if we can reproduce that. Okay. So again, that's why in the first part here I didn't just process these on the fly. I actually wanted to store them into an array of strings because I knew that this was coming up and that I would have to compare string to string. And the first solution that we're going to go with here is going with the naive solution, where I'm going to go ahead and compare every pair of strings. So come down here. I no longer need this. And in fact, I can get rid of this function too. Right? So I do need another function though. I am going to write another function that takes two strings. So, but before we do that, let's go ahead and write up the framework here. So for int I equals 0, I is less than n minus 1, and I'll explain that in a second here. For int j running from I plus 1, j is less than n, j plus plus. So this is a pretty idiomatic nested for loop for running over all pairs. For the first outer for loop, I'm running from 0 up to n minus 2. I'm stopping short of n minus 1. Because what I'm going to be doing is I'm going to be comparing the ith value to the jth value. And so I'm going to go to the end here, and I'm going to compare the second to last value to the last value, but I don't want to compare the last value to a value that doesn't exist. So I stop short, right? And now in the inner for loop, I'm going to start j at I plus 1. Here's I, and I'm going to compare it to everything else in that array. And I only need to start at I plus 1, I plus 2, all the way to the end. I don't have to compare it to anything back there because when I was back there, it compared it with j. So this is going to save me a little bit of work. Right? So for each pair of strings, find if they differ by one character, then you found what you're looking for. Right? So if num or diff char, I'll call it difference in characters of IDs of I and IDs of j. I've not written this function. This is what we're going to do in a second here. If the difference between them is 1, then I'm going to print them. %s and the line IDs of I and print s IDs of j. And then I won't bother, writing code to take out the offending character. Instead, I'll just take care of that manually since these are small enough. I want to avoid that work here. Okay, so what is this function going to do? Well, it's going to take two strings. I'll call them A. And it's going to go through them and find out how many characters they differ by. So all we need to do for that is a simple counter. We'll initialize it to 0. Now for each character in A, then we're going to go ahead and compare it to the character in B. So if A sub I is not equal to B sub I, then we'll increment our counter. Right? So it counts up the number of characters that these two strings differ by. Right? It could be 0 if they're exactly the same string, or it could be the length of A if they're completely different strings, like A, B, C, X, Y, Z. That'll have a difference count of 3. Right? This is basically also a checksum. It's kind of a Hamming distance kind of thing, where you take two bit strings and the number of bits in which they disagree is their Hamming distance between the two. Okay, let me go ahead and try to compile this now. See if I made any mistakes. All right, looks good, and it looks like we got our answer here. Now this one is the same up until we get to this, right? That Y and that E right there, that is the offending character. If I go back over here, we see this one, right? And we see that blah, 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 I, Q, P, U, I, Q, P, U, and then we go to C. I've removed that Y and that E, right? So, pretty easy to do this just brute force style. Now, before I let you go, I just don't want to just solve this. I want to give you a better solution. Okay, these are pretty small. N was only 255. In fact, let me go ahead and bring up Wolfram Alpha. Those loops that I wrote are basically going to go ahead and do 250 choose 2, all pairs, which is only what, 31,125, right? That's how many times those loops will execute. For a computer, that's nothing. Now we got probably lucky and found the two strings that we were looking for somewhere in the middle. So we probably didn't do all 31,000 loops. We probably did 15,000 instead. It doesn't really matter. 100,000, 200,000, those will go by unnoticeable to a human. But consider doing this with, say, 1 million. How many pairs are there of 1 million choose 2? That's going to be about 500 billion, right? See? So 500 billion starts to get noticeable. If they had given us this that much output, of course, then they would have been delivering us megabytes and megabytes of data. They probably didn't want to do that. But if they had been doing that, then this would take quite a while, right? Minutes, hours, days, depending on how big it is. Even with n being a million, that's still noticeable. If I'm doing this really quick, I'm definitely not going to make it onto the leaderboards. Not because I'm a bad programmer. Well, not because I programmed it bad, but because of the computational complexity of the algorithm I did. So I programmed it poorly. So what I'm going to do is I'm going to give you another solution here. First of all, this is a working solution. I'll go ahead and comment that out. It's an observation that, hey, look at this input, right? What if I sorted it? If I sorted it, then the two things that agreed mostly, so here's my strings. They agree in the first one, the second one, the third one. Oh, they disagree in the fourth one. If I'm going to sort them, those two that disagree at exactly 1 are going to be right next to each other, right? And so if I sort it, I don't have to go through everything and comparing every single pair. I only have to go through it once and compare the current one, the ith one, to the next one. And I'm eventually going to find it, given the guarantee that there's a pair of strings exactly like that. So I don't need to compare every single pair, okay? So what I'm going to do is I'm going to go ahead and sort it first. Qsort. I'm going to sort my IDs. Well, what am I storing in it? I'm storing char stars. How many of them are there? There were n, right? N was my 250 value here. How many are there? How big are they? Well, it's size of char star. And then finally, how do I sort strings? I'm going to come back and give you a little bit of mini review from a couple of weeks ago. But now I only need to go through it once. I only need one for loop. I is less than n. Again, I'm only going to go -1 here because I don't want to compare the second to the last one to the last one, but I don't want to compare the last one to something that doesn't exist. I++, and I'll take this down here, right, and uncomment this. Oops. Format it nicely. There we go. And it's not j, it's going to be I+1. Okay? And also, I mean, we can also quit out of this if we want to, once we've found what we're looking for, right? So that we don't, if we get lucky and we find it in the first few, then we don't have to do the entire program. Okay? Now, how do we sort strings? strcmp. Let me go ahead and try that. First of all, hopefully it'll complain about that. Yes, it does. But it only complains. It only gives me a warning. Let me go ahead and run it and see what happens. Right? It didn't find any strings. We know that there are 2 strings like that, but it didn't find them because we probably corrupted a lot of memory here. It didn't end up with a segmentation fault because I think that we allocated all of those on the heap. So even though we were corrupting a lot of stuff, it was a lot of our own memory that we were corrupting, and it didn't end up with a segmentation fault. So why didn't this work, and why was this warning here? strcmp is not a comparator. Look at that. Const char star, right? A comparator takes a const void star. So first of all, this is not even a comparator. Second of all, even if you redesign the comparator, remember we covered this in class a couple of weeks ago. In fact, let me go ahead and open that up. Let's see, where is it? The notes from that is. When we were covering searching and sorting here, strcmp, we'll look for that. All right, there. Remember sorting strings and C, this is we can look at the markdown markup of this. Let me open it up in its new window so we can see it fully. All right, I'll go ahead and increase the size for you. Okay, I'm not finding, that's not going to be useful. Let's go down here, searching and sorting, and then miscellaneous and summary. We went through sorting strings and C. Here's what I want. So you cannot use strcmp because it's not technically a comparator. The solution is that you're going to have to write your own string comparison, and that's what we did in class. Let me walk you through this one more time though. When we're given A and B, they're const void star pointers. Now, qsort is given an array of pointers. So when it looks at these 2 things, this char star and this char star, it's looking at these 2 things and saying, should I go ahead and swap them or leave them alone or something, or they're equal and so I'll leave them alone or something, or if it does a partition, which side does it go on? These are char stars, right? They're pointers to these strings over here. So what qsort does is it hands them off to your comparator, but it does so via pass by reference. In other words, it puts an ampersand in front of those 2 things, making those char star, we'll just focus on one here, char star becomes a char star star, a pointer to a pointer. And that's why in here, we cast it as a const char star star, a pointer to a pointer, because that's what it is. That's what qsort has made it into in order to give it off to your comparator being this comparator right here. So we've got a const char star, and we want to use strcmp, but we've got a pointer to a pointer. Well, we need a char star. To do that, we simply dereference it, and it becomes exactly what we want, a const char star. Then we pass it off to strcmp and let it do the heavy lifting for us to determine, does this string come before that string? So I'm going to go ahead and cut and paste this. There we go. CMP string. And instead of strcmp, we'll use CMP string. Now when I compile, it doesn't complain at all. Because now it follows the required the function signature for a comparator. I'm going to go ahead and run it, and there I get the exact same thing. Now, it's not going to look to the naked eye that this is a much better solution, but it is. All right, let's go back to Wolfram Alpha if I still got that open. All right. So before, if we had 1 million of these things, we'd be looking at 500 billion comparisons, roughly. Well, this, I've cut it down to only 1 million, so that's 10 to the 6th times, times log base 2 of 10 to the 6th, right? That's going to be quicksort, right? That's the average case running time. It's going to make that many comparisons, that many on average. So this is about 20 million instead. And then we go through it again 1 million times, but that's shadowed, that shadows in comparison to the cost to sort it. But 20 million versus 500 billion, right? There's no contest here. This would probably still, even if I had 1 million n being 1 million, this would probably still execute in a matter of moments where it's not even noticeable. Whereas if we had gone with the naive solution down here, the brute force solution, it's probably going to take at least several minutes to execute, if not more. And unfortunately, I don't have an input that large to actually test it and benchmark it with. I'll leave that as an exercise, though. All right, so I'll be back tomorrow with day 3. Hopefully you've enjoyed it, and I'll see you tomorrow. Merry Christmas.